Hello everyone, this is Manish Sharma from skillableindia, and in today's session we are going to discuss the topic which is the actual minimum material envelope. Okay, in the previous session we have discussed about the actual meeting envelope. It is similar to that, but it is almost opposite to the actual meeting envelope. Okay, why it is? We will be discussing each and every point in this topic. Okay, so what is actual minimum material envelope? So I've already told you that it is an opposite of actual meeting envelope. Actual meeting envelope is an envelope which is outside the material. Okay. So basically, actual meeting, in the previous session we have discussed actual meeting envelope. So actual meeting envelope is an envelope which is outside the material. Okay. We are discussing the outside the shaft. We are creating an envelope which is outside the shaft. Okay. We are creating an envelope into the hole which is inside the hole. Okay. So the outside the material we are discussing this concept of actual meeting envelope. But actual minimum material envelope, which is in today's session what we are going to discuss, for this actual minimum material envelope is the one which is inside the material. Okay, so this is also called the imaginary envelope. So in this particular actual minimum material envelope, we are going to discuss inside the material. So we cannot go inside the material. So that's why this actual minimum material envelope is actually an imaginary envelope. Okay, so this envelope is also called an imaginary envelope. So as per the standard, this is the definition. Actual minimum material envelope is an envelope that is similar perfect feature. Okay, so similar perfect feature or the smallest size that can be contracted about an internal feature of internal feature, so that it coincides with the surface of the lowest point. In the previous session, in actual meeting envelope, we are getting the high points. Okay, we are getting the high points of the shaft or high points of the hole. In this actual minimum material envelope, we are getting the low points. Okay, so the low points of the shaft, the low points of the hole, because this is the imaginary envelope which we are creating inside the material. Okay, so similarly, it is similar concept. Okay, so don't worry about it. So we are going to discuss with the help of one example. Okay, so in this example, you can see a shaft here. Okay, so in this example, you can see this is a shaft. Okay, so in this shaft, there is an envelope. Okay, so in this shaft, this is an envelope. Okay, this is an envelope. Now this envelope expands. Okay, so now this will expand in this side and this side. Okay, so when this envelope will expand, it will touches the low points of the shaft from inside the shaft. Okay, so this envelope is inside the shaft. This envelope is inside the shaft. That's why we called it imaginary envelope. Okay, now this envelope will expand. This expand in such a way that it touches the low points of the shaft. Okay, so you can see now after expanding, it is touching this point and this point. So these are the low points of the shaft. So this is the envelope which is the maximum one. Okay, so this is the maximum envelope which can enter into the shaft. Okay, it touches the extremities of the shaft at lower ends. So this is the extremities points which is touching the lower points of the envelope. Okay, so this envelope is called the actual minimum material envelope. So this envelope is known as actual minimum material envelope. Minimum material envelope. Okay. This actual minimum material envelope is also of two types. First one is unrelated actual minimum material envelope, and the second one is related actual minimum material envelope. Okay, in the previous session, we have already discussed this point that what are the difference between the unrelated actual meeting envelope and related actual meeting envelope. So it is moreover same concept, but it is inside the material. Those concepts for the outside the material, which are creating actual envelopes for taking the size, feature of size. Okay. But in this concept, they are imaginary one. Now, in the unrelated actual meeting envelope, you can see this is unrelated example. Okay, example of a shaft. So it is also similar perfect feature counterpart contracted. So these are the this is envelope. Okay, so let's say this is envelope. This is closed from here. Okay, this is an envelope. Now this feature counterpart when contracted towards contracted about an internal feature or expanded to within an external feature. So now this will expand. Okay, this will expand in such a way that it will touches the low points and not constraint, and the external feature, in this external feature, this will not be constrained with the reference datum. Okay, so it is not going to be reference with the datum for unrelated one. Okay, so for expanded, it will expand within an within the shaft. Okay, and not constrained to any datum reference, and not constrained to any datum reference. Constrained to any datum reference. Okay, so now you can see after expanding this, after expanding, it touches the low points of the shaft. Okay, so this is the maximum size envelope which can be imagined enter into the shaft. Okay, so this is the actual, sorry, not actual meeting envelope, it is unrelated actual actual minimum material envelope. Okay, so I will write down here actual minimum material envelope. Okay, now we will understand. So now we are going to discuss, we have discussed for the shaft, now we are going to discuss for the hole. Okay, so in this example, this is the external feature, and this is the internal feature. Okay, so in internal feature, you can see these are the envelope lines. Okay, so if we want to create an envelope and which touches the low points of the hole, okay, so this will be contracted. These lines will be contracted towards the hole. Okay, so this line will be contracted towards the hole. This line will be contracted. After contracting these lines, okay, so now you can see after contracting, these lines will start touching the low points of the here, and these are the low points of the hole. Okay, so this is envelope not taking this envelope is also not taking any reference of the datum. Okay, so this in this also actual minimum, sorry, this is minimum material envelope. Minimum material envelope. So this envelope hence this envelope is not taking the reference of the datum. So not taking reference of data. Okay, so this is, we are discussing the unrelated actual minimum material envelope for the internal feature. Okay, and this is touches the low points of the hole or the feature. Okay, so hence this is also called the unrelated minimum material envelope for the internal feature of size. Okay, now we are going to discuss the related actual minimum material envelope. Okay, so actual minimum material envelope What is related actual minimum material envelope? It is an envelope similar perfect feature counterpart about an internal feature or expanded with an external feature. Okay, so it will expand for the internal feature while constrained in orientation. Okay, so now you can see when it will constrain to an orientation. Orientation we are discussing for the this. Okay, so it is having the orientation location in location or both the applicable datums. Okay, so this envelope is using datum as a reference. So in this case, envelope is using reference datum as a reference. Okay, so now in this example, I have already told you we have an external feature of size, and the we are also going to discuss about the whole for internal feature. Okay, so for external feature, we have imaginary envelope. So this envelope is an imaginary envelope. Imaginary envelope which expands and touches the low points of the external feature from inside. Okay, at the same time, it is taking the orientation of datum reference. So this is the example of the related actual minimum material envelope for the external feature. Okay. Now we are going to discuss for the internal feature. So similarly, we have internal feature for which this is an imaginary surface. So these are imaginary envelope. Okay, these both are imaginary envelope because they are inside the material. Inside the material. Inside the material. For which they are imaginary envelope which contracts, they will contract. Okay, so they will move towards the hole and touches the low points of the hole. Okay, again this envelope in this case you can see now they are touching the low points of the hole. So you can see these low points. Again, this envelope is also taking as a datum as a reference of orientation, as also maintains and hence this is the example of the related actual minimum material envelope. Okay, so this is all for today's session. If you have any doubts, please discuss with us. Thank you. Thanks a lot.